Alright, so I don't know about you, but I find that some of those images about the unit circle that has like all of the angles and all of the sine cosine values already included on it can be really overwhelming to look at. So I want to give you a couple of methods to cut your unit circle into pieces and kind of understand where some of the angle measures are coming from, especially in terms of radians, and how to connect those back to degrees in a quicker way. So there are a couple of things that you just have to know about the unit circle to begin with, and that you have to know about radians to begin with. The first being the x-axis in this direction represents 0 degrees and also 0 radians. And then you need to kind of just know that halfway across is going to be pi, or 180 degrees. And that continuing the entire way around is going to get you back to 2 pi, or 360 degrees. But honestly, the most important thing that I remember here is just that 0 to pi. Because if you can build the top half of your unit circle reliably every single time, then the bottom half is just a reflection of that, and it's not going to be a big logical leap to also master the bottom portion of your unit circle. Okay, so first things first. A lot of times it's hard to understand where they get things like pi over 2. How do I know that pi over 2 is just 90 degrees? How do I make that connection? Well, I think about physically taking this amount from 0 to pi and cutting it into fractional pieces. So if I'm talking about pi over 2, what I've actually done is just taken that entire degree measure of pi and cut it in half. And so it winds up being exactly 90 degrees because 180 cut in half is 90. So if I want to start building my unit circle, that's where I'm probably going to start, is by cutting this in half, and it becomes pi divided by 2. Okay, so now let's also talk about how to find pi over 3 and pi over 6, because those are some challenging ones as well. If I want to look for pi over 3, well, I'm literally taking the amount pi and cutting it into 3 pieces. So think about taking this entire amount and cutting it into 3 perfect slices. It would look something like this. Here's my first third, and then this is my second third, and this is my third one. So this is just pi over 3. Oops. How about pi over 3? That's 1, and then 2, and then 3. So this is 2 pi over 3. So that's how I remember those ones. Now, if I want to cut it into 6 slices, that's just a matter of cutting each one of those ones in half as well. And if I cut each of those in half, I get pi over 6. So I want to find 1, 2, 3, 4, 5, 6 slices. I'm cutting pi into 6 different slices. So that's going to be a matter of looking like this. 1, 2, 3, 4, 5, and then 6. So this is pi over 6. This is 2 pi over 6, or more commonly pi over 3. This is 3 pi over 6, 4 pi over 6, 5 pi over 6, and then finally 6 pi over 6. Okay. Also, it's really important to think about the angles as we go along here. So let me backtrack to pi over 3. You're taking pi and cutting it into thirds. What do you get if you take 180 and cut it into thirds? Well, 180 divided by 3 is 60. And it makes sense that that's a larger angle because cutting something into 3 pieces results in larger pieces, but cutting into 6 pieces gives you smaller amounts. So that's why the pi over 3 is actually corresponding to a 60-degree angle, whereas pi over 6 is only a 30-degree angle, because 180 divided by 6 is just 30. Okay, so the last angle that we're going to look at is the pi over 4 angles, which is literally just 1/4 of pi. So I'm looking at taking this entire measure of pi and cutting it just into fourths. So that's exactly straight through here, and then 1, 2, 3, 4. So that's where I'm just getting these angle measures, which is pi over 4. This becomes 2 pi over 4, and then 3 pi over 4. And the last would be 4 pi over 4. So what I hope you're noticing as I've been counting around through the top half of our unit circle is that you would just continue doing this through the bottom half of the unit circle as well. So if I'm looking at cutting things into thirds, let's say pi over 3 angles, and maybe I want 5 pi over 3, I would just count 1, 2, 3, 4, 5. 5 pi over 3 would wind up right here. This is 5 pi over 3, because then it would be 6 pi over 3, and 6 divided by 3 is 2 pi. So I know that I'm just going back that 1/3 amount, something like that. So as long as you can master the top half of your unit circle, you're going to be just fine with the entire unit circle, because you keep counting that way around the entire around the entire unit circle. So hopefully this has been helpful in understanding where these measures actually come from, how to count them along your unit circle, and also how to quickly relate the radian measures to the degree measures. So just again, thinking in terms of, well, if pi is actually 180, well then pi divided by 6 is just 30 degrees. Or pi divided by 4, 180 divided by 4, well, that's 45. So that's a nice quick way of making these unit conversions, but also building your unit circle.